This lesson is going to look at trigonometry, and specifically in this one I'm going to look at finding missing side lengths. We're eventually going to get to that once we talk about a bunch of other things dealing with trig. The first, I'm just going to look at where the word trigonometry comes from. If you look at the Greek words, the trigon, that's meaning triangle, and ometry, meaning measure. So trigonometry is going to have something to do with measuring triangles. We're going to look at measuring sides, and we're going to look at measuring angles eventually. But what I'm going to look at is another definition would just be the study of the properties. Well, that's going to come down to the angle measures and to the side lengths. Under here, big thing that we're going to look at are going to be these ratios. So keep in mind when we're working with trigonometry, we're going to look at ratios, something that we've looked at in the past. Now, this is just a helpful acronym to help you remember the trig functions, which are sine, cosine, and tangent. So the SOH, let me scroll this down a little bit so that we get it all. Remember, they are ratios. Sine, remember, is the opposite side over the hypotenuse. So, SOH, that'll help you remember how to come up with sine. The C stands for cosine, and cosine is the ratio of the adjacent side length over the hypotenuse. And then our last one is tangent, and that's the ratio of the opposite side over the adjacent side. So keep that SOHCAHTOA in your head, put it in your notes, implant into brain, keep it handy, it's going to be helpful for you. Now here's what I'm going to actually do. We're going to look at sine first, and remember that it's a ratio, and when we work with trig, we're going to go from an angle. This first one talks about sine of A. I'm going to start at angle A. Now, from angle A, I need the opposite side over the hypotenuse. Well, from angle A, if I go opposite, that's going to put me at the length of segment BC, and then the hypotenuse is segment AC, so then I need the length of segment AC. The ratio of the sine of A is going to be the length of segment BC over the length of segment AC. Now, if I change this and now go to angle C, well then, my sine of C is going to be different. It's still going to be the opposite side over the hypotenuse. My hypotenuse doesn't change in this triangle. However, if I'm now at angle C, the opposite side would be segment AB. Therefore, I need the length of segment AB. Opposite over hypotenuse for the sine of C. Opposite over hypotenuse for the sine of A. Come over here and look at the cosine now. Remember, cosine is adjacent over hypotenuse. And again, if I start at angle A, now this time I need the adjacent side, the side that's next to it. That's what adjacent means. Now you have to be careful because technically there's two sides that are next to angle A, but the hypotenuse will not be the adjacent side for what we're going to look at. So we're going to go to the other side. My cosine of angle A then is going to be the length of segment AB, and now again over hypotenuse, length of segment AC. When I change it and go to now angle C being my angle, I'm still going to do the adjacent side over the hypotenuse. Well, we've already figured out that the hypotenuse is segment AC, therefore I need the length of segment AC. And then the adjacent side here, remember it's not going to be the hypotenuse, it's the other one that's next to angle C. That's going to be the length of segment BC. There's cosine for that triangle. And then the last trig function that we're going to look at will be tangent. And we're going to do the same thing. We're going to go from angle A and angle C. First I'll look at the tangent of angle A. If you think back to the SOHCAHTOA, TOA, tangent is opposite over adjacent. Therefore I need to go to the opposite side from angle A, and that's going to give me segment BC. Therefore I need the length of segment BC here. And then I also need to go to the adjacent side. The adjacent side. That will be the length of segment AB. When I change this, and now go and take a look at the tangent of angle C, get rid of this stuff, well, the side opposite angle C is now segment AB. I need the length of segment AB, then over the length of the adjacent side length, which will be the length of segment BC. And what you'll notice here when you work with tangent, if you go from the tangent of one acute angle versus the tangent of the other acute angle, the ratios are just going to be reciprocals of each other. Now let me throw some numbers in there. I have my probably most famous right triangle, the 3, 4, 5 right triangle, and I want to find the sine, cosine, and tangent of the two acute angles. If I start with the sine of x, let's just go through and let's look at all of the trig functions from angle x. Start with sine. I need to go to the opposite side. So from angle x, the opposite side is 4. The hypotenuse is 5. So the sine of x in this problem is going to be 4/5. If I go to cosine, now remember cosine is adjacent over hypotenuse. My hypotenuse is still 5. That's not going to change. But now when I come up here to angle x and I look for the adjacent side, the one that's next to it, that's going to be the 3. And last but not least, tangent. Tangent is opposite over adjacent. The side opposite the angle x is the side that's 4 units long, and the adjacent side is 3 units long. So 4/3. Now my other row, I'm looking at the sine, cosine, and tangent, but now from angle z. Well, opposite angle z is the side that's 3, hypotenuse is still 5. Cosine of angle z, now I need the adjacent side, which is now 4, hypotenuse is still 5. And then my tangent of z, opposite the angle z is the side that's 3, the adjacent is the side that's 4. I just got done talking about tangent, and if I look at the tangent of the two acute angles, their answers are just going to be the reciprocals. So here I have 4/3, here I have 3/4 reciprocals. When you come over here to sine and cosine, if you look at the sine of one acute angle, and then relate that to the cosine of the other acute angle, notice they're equal. Come here, I have 3/5 for the sine of z, 3/5 for the cosine of x. And that's always going to happen. The sine of one angle will equal the cosine of the other acute angle in a right triangle. Now comes a little calculator work. On here, what you need to make sure of first is that your calculator is in degree mode. If your calculator is not in degree mode, this will not work. And if you need some help with your calculator, let me know. All I'm going to do is I'm taking my calculator and I'm going to push all these numbers, the sine of 30, and show you the answer. The first one it asked us to look at would be the sine of 30. On my calculator, then, if you have a graphing one like I do, you're going to push sine, type in 30, and push enter. You should get an answer of 0.5. Now, some of you are going to get a different answer, and I'll show you that answer here real quick. If you have your calculator in the wrong mode, so say it's in radian mode, and now I do the sine of 30 again, I'm going to get a different answer. What I want us to do is you'll get that negative 0.98, so on and so forth. I want you to make sure that you are always in degree mode. Everything that we're going to do with trig, we're always going to work in the degree mode. So make sure your calculator is in degree mode. If it's not and you don't know how to get it into degree mode, let me know. So when we type in sine of 30, we should get an answer of 0.5. Now the other one that I had on the notes would be the cosine of 60. Push enter, notice 0.5. Now remember, sine of one angle is going to be equal to the cosine of the other acute angle in a triangle. Well, if one of the acute angles is 30, the other one's going to be 60. That's why these come out to be the same number. And the last one that I had in my notes was the tangent of 45. If I push enter, that comes out to be 1. Now they're not always going to come out to be these nice decimals of 0.5 and 1. You know, if I take some, like the sine of, say, 19 degrees and push enter, I get a messy decimal, and that's going to happen a lot when we work with trig. It's okay to not always have integer values or whole numbers for our answers. So come back here just to fill this in. I typed it on my calculator. I ended up with 0.5 or a half. I typed this in on my calculator. I ended up with 0.5 or 1/2. And I typed this in, and I ended up with an answer of 1. I'm going to show you why that's beneficial, because of this. Now this triangle, you'll notice I have the 60-degree angle, the 90-degree angle, and then obviously this is going to have to be the 30-degree angle. This is our 30, 60, 90 triangle. based off the information that you learned about a 30, 60, 90 triangle, this is going to be very quick to figure out. The short leg is always half the hypotenuse, therefore that's 5. And then if we multiply the short leg by root 3, we get the long leg. Now I'm going to show you how we can find those side lengths using trig as well. I would strongly recommend using the properties of a 30, 60, 90, but I'm going to show you how trig can work as well. So what I'm going to do is ignore the blue for the time being, and really don't worry about this because you don't need it. I'm going to go from that 60-degree angle. And first I'm going to look for x. I'm going to look at this and go, well, from the 60-degree angle, the x is the adjacent side to the 60-degree angle, and I know the 10, which is the hypotenuse. Now I got to think back to my trig functions. I'm working with adjacent hypotenuse. Which trig function deals with adjacent and hypotenuse? Well, the answer to that is cosine. Therefore, I'm going to use cosine, go from the angle that I know, it's 60 degrees, and now cosine of 60 is equal to adjacent, which is my x, over my hypotenuse, which is 10. All I have to do here is put this over 1. I can put anything over 1, doesn't change the value. But what that does is it makes a proportion. Now I can solve my proportion by cross multiplying. I find out that x equals, now this is where I just type this on my calculator. If I go back to my calculator and I type in, I like to start with the number 10 times the cosine of 60, and then I push enter, and notice it comes out to be 5. Well, if we go back to our properties of a 30, 60, 90 triangle, it was supposed to be. But here's how trig works to verify that that actually comes out that way. Now, the other one, I want to find the value of y. And I wouldn't use this number because sometimes that's going to be a messy decimal. It's not going to be exact. Always go back to the number it gives you, so the 10. Let me get rid of these. And now I'm going to go, well, I still know my 60-degree angle. Now this time, I'm looking for the opposite side, and I know the hypotenuse. That trig function, opposite and hypotenuse, is sine. So I'm looking for the sine of 60 degrees, that's my angle. Sine, remember, is opposite, which in this case is our y. We don't know it yet, and our hypotenuse is 10. Same thing's going to happen here. I'm going to make a proportion, and now I can solve. If I cross multiply, I get y equal to, and now this is where I'm going to have to type that on my calculator. Come back here and type in my 10. I want to multiply it by the sine of 60. And notice I get 8.66 approximately. So I'm actually going to change this from an equal sign because I'm rounding, and I ended up with 8.66. And you're going to look at this and go, well, that doesn't really match what I have here. But it actually does. Come back to our calculator and type in 5 times the square root of 3, and you get that exact same decimal of 8.66, and then all the rest of them. So yes, these two things are pretty close to being equal. This one's been rounded, there's the exact. When you work with trig, in many cases you're only going to be able to come up with the approximate value. I want to look at one more example. In this one, I have a 12-degree angle. I have one leg of my triangle I'm looking for and the hypotenuse. So you just have to decide which one you want to find first. I'm going to say, let's find the hypotenuse first. And then I look at this, and from my 12-degree angle, I know the adjacent side, and I'm looking for the hypotenuse. That's cosine. So the cosine of the 12-degree angle that I went from, cosine is adjacent, which is 15, over hypotenuse, which is c. Turn this into my ratio. Now I can cross multiply. So here I'm going to get 15 equal to, cross multiply this way. Now I'm going to have c times cosine of 12 degrees. Now remember, I'm trying to get c by itself. Continue on, I'm going to divide both sides by the cosine of 12. And the reason I do this is to get that c by itself. Cosine of 12 will divide out there. If I divide one side by the cosine of 12, I have to divide the other side by the cosine of 12. Now I can go to my calculator, I can just type in 15 divided by the cosine of 12. I'm going to take 15 divided by cosine of 12, and push enter, and I get approximately 15 point, I'm going to go 2 decimal places, 15.34. So 15.34. My hypotenuse, 15.34. Approximately. Notice, it is bigger than that leg, not by much, but it is bigger, which it should be. And then if I'm going to go to R, well now, I'm looking for the side that's opposite from the 12-degree angle, and I know the adjacent. Remember, I do know the hypotenuse, but being that was a rounded number, I'm going to go to the 15 that I know is exact for this problem. Trig function that deals with opposite and adjacent is tangent. Therefore, I'm going to want to work with the tangent of the 12-degree angle. Remember, tangent is opposite. Opposite side was the R over adjacent, which is 15. I have my ratio, turned it into a proportion, cross multiply. This one's going to go a little faster. So R is going to be equal to the tangent of 12 degrees times 15. Just a matter of typing that on my calculator. So 15 times the tangent of 12, and I end up with an answer of approximately 3.19. Be the length of that other leg in my triangle. So now you have multiple ways to find missing sides in right triangles. You have the Pythagorean theorem. You have properties of 45, 45, 90 triangles, 30, 60, 90 triangles, and now you can also use trig. Use whatever method works best in the different situations. If you have questions, let me know, especially if it's any question on calculators.